Welcome! In this video, we will tackle about fuzzy logic. What is fuzzy logic?
There's a new fact sweeping the world: system design is powerful, intelligent, adaptive, and this might be the key to evolve to the better future. What it is? None other than fuzzy logic, a new way of thinking about old problems. Fuzzy logic-based systems have been growing popularity in this recent year. And now, fuzzy logic can be found in household appliances like rice cooker and washing machine. But what is fuzzy logic? Fuzzy logic is a logic operation method based on many valued logic rather than binary logic. Two valued logic often consider 0 to be false and 1 to be true. However, fuzzy logic deal with truth value between 0 and 1, and those values are considered as intensity of truth. Fuzzy logic can be used to describe how information is processed inside human brain. For example, it can be argued that humans do not know the difference between fat and thin. 5 people may be fat and not have the same severity of fatness, or one person may appear thin compared to another, while both are actually fat. Using fuzzy logic, you can assign different logic value for fatness, ranging from 0 to 1 according to each severity of fatness. Mathematical logic that attempt to solve problem by assigning values to an imprecise spectrum of data in order to arrive the most accurate conclusion possible. Fuzzy logic is designed to solve problem in the same way that humans do, by considering all available information and making the best possible decision given the input. For example, take the apple. It is something an apple or it is not? It seems like a simple question, but it's actually a more complicated one. For example, say I take a bite out of the apple. It is still an apple? Obviously right. Now, say I take another and another until only a half of apple remains. It's still an apple? And now, what about when the core only remains? Or what about when not even that remains? It is an apple? At what point the apple cease being an apple? In Boolean logic, we must assume that there's a definite point when the apple across the line of being an apple to not an apple. But it is not clear what point is. Fuzzy logic allows us to see the changing apple while it's still in process of being eaten. So now, our whole apple is 100% apple and our half apple is 50% apple, and when the apple is completely eaten, it is 0% apple. With fuzzy logic, we embrace the shade of gray that allow an apple to go from whole to core. The apple example illustrates how fuzzy logic allow to break down the problem in a way to make more natural to people. Fuzzy logic first proposed by mathematician Loftus Sadeh in 1965. Fuzzy logic precision and significance in real world. Fuzzy logic is a convenient way to map an input space to an output space. Mapping input to output is a starting point for everything. Consider the following as example. With information about how good your service in the restaurant, a fuzzy logic system can tell you what the tip should be. With your specification of how hot you want the water, a fuzzy logic system can adjust the faucet valve to the right setting. With information about how far away the subject of your photograph is, a fuzzy logic system can focus the lens for you. And with information about how fast the car is going and how hard the motor is working, a fuzzy logic system can shift gears for you.
The fuzzy set theory. As you can see, this is the difference between the sample graphs of classical sets and fuzzy sets. Fuzzy sets can be considered as an extension and gross oversimplification of classical sets. It can be best understood in the context of set membership. Basically, it allows partial membership, which means that it contains elements that have varying degrees of membership in the set. From this, we can understand the difference between classical set and fuzzy set. Classical set contains elements that satisfy precise properties of membership, while fuzzy set contains elements that satisfy imprecise properties of membership. Now, we will discuss about the operations on fuzzy sets. Having two fuzzy sets, A and B, the universe of information U and an element Y of the universe, the following relations express the union, intersection, and complement operation on fuzzy sets. The first operation is the union or fuzzy OR. Here, the union represents the max operations. Let us consider the following representation to understand how the union or fuzzy OR relation works. As you can see, we have three different graphs. A graph for fuzzy set A, fuzzy set B, and the union of two fuzzy sets. And you can also observe the general solution for union. It is set A union with set B with the universal Y and the existential U. The second operation is the intersection or fuzzy end. As you can see, there's not much of a difference between the graphs of union and the graphs of intersection. We also have three graphs for fuzzy set A, fuzzy set B, and the intersection of two fuzzy sets. Here, the intersection represents the minimum operation. The general solution for the intersection is set A intersects with set B with the universal Y and the existential U. And last but not the least, the operation complement or fuzzy knot. Here is an example of a graph for the complement of a fuzzy set. The general solution for the complement or fuzzy knot is 1 minus the fuzzy set A, Y, with the universal Y and existential U. For properties of fuzzy sets, the first property is the commutative property. As you can see, we have two sets, set A and set B. This property states that if set A is union with set B, it is equals to the union of set B to A. Or if set A intersects with set B, it is equals to the set B intersects with set A. The second is the associative property. We have three sets here, A, B, and C. This property states that if A is union with the union of B and C, it is equals to the set A union with set B union with set C. Or if set A intersects with the intersection of B and C, it is equals to the intersection of A and B intersects with C. The next one is the distributive property. We also have three sets here. This property states that if set A union with the intersection of B and C, it equals to the intersection of the union of set A and B and the intersection with the union of set A and C. Or if set A intersects with the union of B and C, it is equals to the intersection of set A and B, the union with the intersection of A and C. Then, the idempotency property, we have only one set, the set A. It states that set A union with set A is equals to A. And if set A intersects with set A, it's equals to A. And the identity property is equals to set A and the universal set. The property states that if set A is union with the arrow, it is equals to set A. And if set A intersects with the universal set, it is equals to set A. And if set A intersects with the arrow, it is equals to arrow. And if set A is union with the universal set, it is equals to the universal set.
The meaning of the expression cold, warm, and hot are represented by a function mapping in the temperature scale. A point on this scale has three truth values, one for each of the three functions. The vertical dashed line in the image represents a particular temperature that the three functions gauge. Since the function for cold is at 0.8, the temperature may be interpreted as very cold. The function for warm is at 0.2, may describe it as slightly warm. And the function for hot is at 0, which may be interpreted as not hot. This is the tree process. Classify all input values into fuzzy membership functions. Execute all applicable rules in the rule base to compute the fuzzy output functions. Defuzify the fuzzy output functions to get crisp output values. Fuzzy sets are often defined as triangle or trapezoid-shaped curves. They can also be defined using a sigmoid function. One common case is the standard logistic function defined as s of x is equals to 1 over 1 plus e raised to negative x, which has the following symmetry property. S of x plus s of negative x is equals to 1. From this, it follows that s of x plus s of negative x times the quantity s of y plus s negative y times quantity s of z plus s of negative z is equals to 1. Fuzzy logic operators. Fuzzy logic works with membership values in a way that mimics Boolean logic. To this end, replacements for basic operators and or not must be available. There are several ways to this. A common replacement is called the Zade operators. For true or 1 and false or 0, the fuzzy expressions produce the same result as the Boolean expression. There are also other operators more linguistic in nature called hedges that can be applied. These are general verbs such as very or somewhat, which modify the meaning of a set using a mathematical formula. However, an arbitrary choice table does not always define a fuzzy logic function. In the paper, a criterion has been formulated to recognize whether a given choice table defines a fuzzy logic function in a simple algorithm of fuzzy logic. Function synthesis has been proposed based on introduced concept of constituents of minimum and maximum. A fuzzy logic function represents a disjunction of constituents of minimum, where a constituent of minimum is a junction of variables of the current area greater than or equal to the function value in this area. If-then rules. If-then rules map input or computed truth values to desired output truth values. Example: if temperature is very cold, then fan speed is stop. If temperature is cold, then fan speed is slow. If temperature is warm, then fan speed is moderate. If temperature is hot, then fan speed is high. Given a certain temperature, the fuzzy variable hot has a certain truth value, which is copied to the high variable. Should an output variable occur in several dead parts and the values from the respective if parts are combined using the OR operator. Defuzzification. The goal is to get a continuous variable from fuzzy truth values. There are no single algorithm for this purpose. 1. For each truth value, cut the membership function at this value. 2. Combine the resulting curves using the OR operator. Find the center of weight of the area under the curve. The exposition of the center is then the final output.
The advantages of fuzzy logic. Fuzzy logic allows for the modeling and inclusion of the contradiction in a knowledge base. Example, tall belongs to multiple sets. Also, it increases the system autonomy, which means the rules in the knowledge base function independent of each other. Compensatory as opposed to the rule based where a single rule can bring about undesirable outcomes. And it also eliminates borderline cases. It prevents microchip processor-based appliances. Fuzzy logic allows you to model in more intuitive way complex dynamic system. Fuzzy logic does not require the models and can be used in nonlinear process. And it also has a high performance. So basically, the basic advantage of fuzzy logic controller is it allows the different operator to merge uncertain information in the best way and incorporate the heuristic control in the form of if-then rule. Here are the other fuzzy logic advantages. Provides flexibility, provides option, frees the imagination, more forgiving, allows for observation, shortens system development time, increase the system maintainability, uses less expensive hardware, handles control or decision-making problems not easily defined by mathematical models.